All right, welcome to another video. I kind of thought about maybe having the camera off for this video, but I just want to not spend a lot of time in this. I'm wearing kind of a weird shirt. I kind of believe in the effects of like the health benefits from like infrared saunas enough to have bought one and used it for the last few days. So I've been using it pretty much as long as I can in the morning and in the evening, which right now is really no more than a half an hour. And like doing this RFC series has been kind of fun for me. So I want to keep doing this. It feels really productive. So this might be a shorter video than usual because I'm not sure. Right now I'm only at the 7-minute mark in here, and I'm already starting to feel it. If you want to know more about kind of my personal life and some of the stuff, just head over to my personal channel. I have various hobbies that I do, and one of those hobbies is I'm trying to get as healthy as possible. Definitely a important thing during this pandemic. So I kind of research into the pandemic and kind of see like what the best ways to handle it are to kind of get through it. So I take like hot cold showers, and I'm using this sauna now, along with various other things. I don't want to talk too much about that. One thing I think it would be irresponsible for me to not say is I did get vaccinated. I've got 3 doses of Moderna, and I have not had a symptomatic case of any kind. So I do urge other people to get vaccinated. I know that might be something that would turn off some people from watching this, but I just feel it's my social responsibility to say that to say that. But as I said, I don't want to spend a lot of time on that. That's not what this channel is about. If you want to know more about me, my personal life and my hobbies, head over to my personal channel. But this is about core content related to furthering my career with computers, and hopefully other people can learn from that. So we're at the 3-minute mark of this video so far, so I'm going to cut it off, do a hard cut off here. Don't want to talk about this anymore. So we're going to focus on this RFC again. We have our next video note here. So in the last video, I read the RFC all the way down to lookup path segment specification. So we're going to start from there and get as long as I can go until I have to leave this infrared sauna. All right, so this is section 3.1, lookup path segment specification. A simple lookup to determine if an object exists or not without returning RDAP encoded results can be performed using the HTTP head method as described in section 4.1 of RFC 7480. So I'm going to do the same approach I did in the last video, where I load up all the background RFCs. I call them lore RFCs, kind of like in an RPG game. You have lore, kind of treating that the same way. And then once it gets loaded up, I'll stop the video and save that, and then come back. The resource type path segments for exact match lookup are IP, used to identify IP networks and associated data referenced using either an IPv4 or IPv6 address. Autonum, used to, so kind of like autonomous system number, autonum, used to identify autonomous system number registrations and associated data referenced using an AS plane or S plane. I guess I'm not sure how that's pronounced. Autonomous system number. Domain, used to identify reverse DNS, RIR, or domain name DNR information and associated data referenced using a fully qualified domain name. Name server used to identify a name server information query using a host name. Entity used to identify an entity information query using a string identifier. Okay, next section is 3.1.1, IP network path segment specification. So it looks like we got a syntax here. We got IP/IP address or IP/CIDR prefix, so that'll be the subnet mask represented in 2 digits, 1, 2, 3, all the way up to /24s are pretty common, /30, and then the CIDR length. Okay, that format's a little bit unclear to me. I guess I'm not used to seeing it written out that way. I think what they actually mean by CIDR prefix is the address, because a CIDR notation, I think, consists of the 4 octets in an IPv4 address, and then a slash, and then the subnet mask represented in 2 digits. So I think that's what that would look like. Hopefully it'll be clarified as we go. Queries for information about IP networks are of the form /IP/XXX or /IP/XXX/YY, where the path segment following IP is either an IPv4 dotted decimal or IPv6. So here's a background RFC that I will save. Address, for example, XXX, or an IPv4 or IPv6 classless interdomain routing, CIDR, which I will save as well. Notation address block, for example, so CIDR notation address block is both the address and the subnet, and then this slash here. Semantically, the simpler form of using the address can be thought of as a CIDR block with a prefix length of 32 for IPv4 and a prefix length of 128 for IPv6. A given specific address or CIDR, CIDR, may fall within multiple IP networks in a hierarchy of networks. Therefore, this query targets the most specific or smallest IP network that completely encompasses it in a hierarchy of IP networks. The IPv4 and IPv6 address formats supported in this query are described in section 3.2.2 of RFC 3986 as IPv4 addresses and IPv6 ABNF definitions. So this is this takes us just to the references here, so it needs an additional click. It doesn't take us right to because it doesn't know which format you want, so this seems like the best way to do it. Okay, and then I will rearrange these from newest to oldest. So, okay, they're already in the right order. Semantically, the simpler form using the address can be, I'm on the next paragraph already. Any valid IPv6 text address format, which we got another RFC here. Can be used. This includes IPv6 addresses written using with or without compressed zeros and IPv6 addresses containing embedded IPv4 addresses. The rules to write a text representation of an IPv6 address are recommended. However, the zone ID is not appropriate in this context. Therefore, the corresponding syntax extension in RFC 6874 must not be used, and servers should ignore it. So that's an important thing to note. We're still going to look into this RFC just for the lore, for the background knowledge, even though it's not going to be used in the context of the whois replacement protocol here, which is described here, which is the, I think it's RDAP, Remote Database Address Protocol, or Remote Database Access Protocol, I think it is. I don't remember. But so we've got 3986. So we'll also open these. For example, the following URL would be used to find information for the most specific network containing 192.0.2.0. Okay. The following URL would be used to find information for the most specific network containing 192.0.2.0.24, .0/24. Okay, so you just put another slash there. The following URL would be used to find information for the most specific network containing this. So I'm not sure. I would like to see an example for the subnet mask on a IPv6 address, which can go up to 128 instead of 32 for IPv4. I assume it's just the same. You just tack it on the end there, but without an example, I don't know for sure. Okay, before moving on, I'm going to arrange these lore RFCs. Okay, so we've got 6874. All right, next section is 3.1.2, autonomous system path segment specification. So the syntax is AUTNUM, presumably standing for autonomous number, and then slash your autonomous system number. This is something we learned about in the videos on BGP. It's typically up to a 5-digit number. It has a private space and a public space, just like IP addresses do. And but there's also an extended format where you can have more digits, kind of like for IPv4, where you also have IPv6. But it's a little bit different than that because it's, from what I understand, it's basically if for IPv4, you could just have a slash 33, 34, 35 address. It just tacks on to the existing syntax and format. It does not create an entirely new one like IPv6 did. Okay, but we might learn about that later in more detail. Queries for information regarding autonomous system number registrations are of the form /autonum/xxx, where xxx is an AS plain autonomous system number. I don't think that RFC is up there yet. It's going to go here. Yep. In some registries, registration of autonomous system numbers is done on an individual number basis, while other registries may register blocks of autonomous system numbers. The semantics of this query are such that if a number falls within a range of registered blocks, the target of the query is the block registration, and that individual number registrations. So the semantics of this query are such that if a number falls within a range of registered blocks, the registration of the query is the block registration, and that individual number registrations are considered a block of numbers with the size of 1. For example, the following URL would be used to find information describing autonomous system number 12, a number within a range of registered blocks. You can see that there. The following URL would be used to find information describing 4-byte autonomous system number 65538. Yep, so it's pretty intuitive. The URL we used, so this is information describing autonomous system number 12, a number within a range of registered blocks. You just tack it on the end there. And then you can use the same sort of syntax to find information describing 4-byte autonomous system numbers. In this case, the private number 65538, just tack it on the end. So I assume to find extended, I think they can go up to 6 bytes. I don't remember exactly. You would just use the same kind of syntax there. Let me look into that quick. All right, so the next section is section 3.1.3, domain path segment specification. The syntax is domain/domain name. Queries for domain information are of the form /domain/4x's, where the 4x's are a fully qualified relative to the root domain name as specified in those RFCs, which we will save. So really, really old ones here. This looks like RFCs for domain name specifications, which are some of the very first concepts for the internet, just where things are, kind of like addresses for houses in a way, or like, I guess more like street names or like neighborhood names would be the better analogy. In either the in-addr.arpa or IPv6.arpa zones for RIRs, or a fully qualified domain name in a zone administered by the server operator for DNRs. Internationalized domain names, IDNs, represented in either A-label or U-label formats. So this is RFC 5890. Are also valid domain names. See section 6.1 for information on character encoding for the U-label formats. IDNs should not be represented as a, so that word should is a little bit confusing, but from what I understand, now let's go back to my prior video, and here's the background knowledge. So the background knowledge we need to fully understand that is going to be one of these oldest RFCs here. So it's going to be this one, published in 1997. Here we can see should not. So let's read a little bit about should not. It'd be nice if I could do a search from the dialog box. No, I can search Google, but I can't search the page. That would be really nice if you could search the page just by right-clicking. I wonder if there's an extension for that. I'm getting off track here, but that would just be so convenient for me. I think it's worth a little bit. So we're going to say Chrome, right-click, search page. Extension. Okay, so it's going to take a deeper dive to see if there's an extension for that, so I'm just going to move on. IDNs, and I forgot to actually read about the, what I was actually looking up. Okay, so should not, this phrase or the phrase not recommended mean, without an S, that there may exist valid reasons in particular circumstances when the particular behavior is acceptable or even useful, but the full implications should be understood and the case carefully weighed before implementing any behavior described with this label. So that's good to know. I actually thought that was the definition of something else. I was thinking that should not meant must not, so I'm glad I got corrected on that. So IDNs should not be represented as a mixture of A labels and U labels. You can decide to do that if you want, but you really need to carefully weigh the reasons why you're doing that. And it's definitely not something that the engineers of this protocol recommend that you do. That is, internalized labels in an IDN should, and again, this means that you can decide not to do this, but you do it against the best wishes of the engineers behind this protocol, be either all A labels or all U labels. It is possible for an RDAP client to assemble a query string from multiple independent data sources. Such a client might not be able to perform conversions between A- labels and U- labels. An RDAP server that receives a query string with a mixture of A- labels and U- labels may convert all the U labels to A labels, perform IDNA processing, and proceed with exact match lookup. In such cases, the response to be returned to the query source may not match the input from the query source. Alternatively, the server may refuse to process the query. So we see that word may popped up multiple times. The server may perform the match using either the A label or the U label form. Using one consistent form for matching every label is likely more reliable. So there's a third time that shows up. Let's refresh what that word means, may. Oh, and I keep closing the thing I need. I should probably leave that open. Okay, so may, this word or the objective optional mean, without an S, that an item is truly optional. Okay, so this means that you can, even if though, so you can choose to do it. If you choose to do it, great. You have the best wishes of the engineer behind this protocol. They're not urging you to do it one way or the other. One vendor may choose to include the item because a particular marketplace requires it, or because the vendor feels that it enhances the product while another vendor may omit the same item. An implementation which does not include a particular option must be prepared to interoperate with another implementation which does include the option, although perhaps with reduced functionality. In the same vein, an implementation which does include a particular option must be prepared to interoperate with another implementation which does not include the option, except, of course, for the feature the option provides. So I think what that meant is you can choose to have it, so you can perform the match using the A label or the U label. But if you pick the A label or if you pick the U label, you still need to be able to interoperate with a vendor that picked the other label that you did not pick. The following URL would be used to find information describing the zone serving the network 192.0.2, and we can see there's only 3 octets. That's because it's a /3024, so the entire last octet will be 0, so they just leave that out. So here's an example of the URL to find information describing the zone that serves that network there. So, okay. The following URL would be used to find information describing the zone serving the network. It's an IPv6 network. If you're advanced at networking, or even if you're still learning it, this should pop out the page at you. This is a special kind of IPv6 address, just like this is a special, actually, never mind. This is a public, because the Class C private range is 192.168/16, I think. Yeah, /16. So now this kind of pops out at the page as me as well, but it might be because it looks similar to a reserved prefix, but it is not actually in that range. And I think that is the case because we can see the reserved prefix range is /32. So we have 1 here, and it's a /48. So we're not operating within the reserved prefix range that is reserved for documentation. So for example, so now you can see so it looks like there's a conversion happening here. We can see it's 2001. Okay, so it gets a little tricky for URLs used to find information describing the zone serving IPv6 networks. I'm trying to figure this. Aha! So I got it. It's backwards. So we can see it's just the same thing, but separated by each digit is separated by a dot, but it's backwards. So the 2 here, 2001, we can see that's the case going the other way. 2001, and then in IPv6, there's various conventions and rules. There are various ways you can condense an IPv6 address because there are 128 bits, so they go on for very long. One of the ways you can condense an address is if it has any leading zeros in the, so these are 2 octets here represented between the colons. You have a set of octets with 2 digits and a set of octets with another digits, which we can see here very clearly. By here, oh no, what happened? We're missing an octet. We're missing a nibble. We're missing a set of 4 bits. So, you know, what is going on here? Well, what's going on is if you have a leading 0 in any of these sections, you can just drop the leading 0 and shorten the address that way. We see that's also happening here in the third set of double octets of 16 bits. There would be normally 3 leading zeros, but we could drop them and just put that one. But it looks like in the URL used to find information describing the zone serving IPv6 networks as part of the RDAP protocol, you can't do that anymore. So not only do you have to list it backwards, you can't have that abbreviation. You have to include that leading zero that was dropped, and then you can see the leading zeros were included for the third instance of 16 bits as well. And then beyond that, it looks like you're fine. You don't need to put in the subnet mask. You don't need to put in any trailing zeros. This, I think, is pretty straightforward to me now. I just kind of wish they had listed it in the other direction. I'm not sure why they made that decision. It kind of makes it a little bit less intuitive. The following URL would be used to find information for the blah.example.com domain name. So you just add that at the end. The following URL would be used to find information for it looks like we got some special characters there, some dashes. So that example, it looks like is proving that you can use those dashes. You don't need an escape character, or you don't need to replace them with special other characters. Okay, so I've been in this sauna longer than I typically am, so I definitely want to cut it here. I don't want to push it on here. Again, if this is a little bit strange, check out my personal channel where I go through some of my hobbies, but I don't want to say too much about that on this channel. This is a core content channel devoted solely to a career in with computers and modern technology. All right, so that's going to be it for this video. I'll do the same thing I did for the last one, where I list the resource, the lore, and then when I come back, the next video will be on this name server path segment specification. Thanks for watching, and see you in the next one.